Hello everyone. In this video we're gonna convert directly from base 2 to base 8 and 16. So if we're gonna convert from binary to base 8, we group them into groups with 3 digits. You start from this side. So we have 101 and convert that. That will give me a 5 as we know. And 100, that will give me a 4. And 000 is 0, and 001 is 1, and 11 is a 3. So this binary can be converted from base 2 to base 8 as 3, 1, 0, 4, and 5. So let's try this example here. So as you see, we grouped this binary number into groups of 3. So the first 101, that is a 5, and then 110, that's 6, and 110 is 6 again, and 010, that's a 2. So basically this number here to base 8 would be 2665. And this is how we convert from binary to base 8. Base 16 is very similar, but instead of grouping 3 digits, we're gonna group 4 digits at the time, starting from this side here. So as you see, this number here, if we group it as with the 4 digits, so 0101, as we know, is a 5. So we have a 5, and then 1000, that is 8, and then 1111, that is 15, which is an F. 1011, it's a B, which is 11 in decimal, which is a B, and then 10, that's 2. And this is how we convert from base 2 to base 16 by grouping them in groups of 4. So here is another example here, similar to what we did, but here I already space it out a little bit by grouping it into 4 digits. So for example, 1001, it's a 9, 1010 or 1010, it's a 10, which is a A, and then 1101, it's a D, and then 10, it's a 2. So this binary to hex, this is base 16, will be 2DA9. But to base 8, we're going to have to group them into groups of 3 and then convert it. So here I copy the digits and I split them into groups of 3. This is 1, this is 5, 6, 6, and 2. So this number here in binary is 26651 in base 8. So now let's learn about addition and place carrying. So here is the algorithm, the same as when you add a polynomial, you have to match the degrees and you add, or match basically the place value. So here you could read the algorithm. Let's see an example. For example, here we have this binary added to this binary. So when I add 1 plus 1, that is 2 in decimal. But 2 in decimal is 10. That means you put down 0 and you carry 1. And then you have a 1. And again, 0 plus 0 is 0, 1. 0 you carry 1. And 1 plus 1, again, 0 you carry 1. 1 plus 1. 0 you carry 1, and 1 plus 1, 0 you carry 1, 1 plus 1, 0 0, 1. Just remember that 1 plus 1 is 2, and 2 in binary is 0, and then you carry 1. Similarly here, if I have 1 plus 1, that's going to be 0 and I carry 1. 1 plus 1 is 0, I carry 1. But right here I have 1 plus this 1 and this 1, so I have 3. So 3 in binary is 1, 1, right? That means I put 1 here and I carry 1. 1 plus 1 is 0, you carry 1. Again, 0, you carry 1. But again, 1 plus 1 plus 1, there are 3 ones. That means you put the 1 and you carry 1. And 1 plus 1 plus 1, 3 ones, meaning 1, 1. And this is how we do addition in binary, and we're going to practice more with addition in binary when we do multiplication in base 2. Now, when you see F and B, this is base 16 or hex, So f plus 2, that will give me 17. When you minus 16, you get a 1. So the answer is a 1. And because you minus 16, it's like you carry 1. Similar to base 10. That's what we do in base 10. So 1 plus 1 is 2. C plus 1 is going to be D. And then you have a B. And then A plus 1, that's B again. So the answer is B, B, D, 2, 1. This one here is base 8. So let's see, 2 plus 2 is 4. 5 and 1 is 6. Then 6 and 5. So here, 6 plus 5, that will give me 11. But I'm in base 8. That means I have to subtract 8. When I subtract 8, we get 3. So we have 3, and you carry 1. If you subtract 2 8s or 3 8s, you carry 2 or you carry 3, and so on. 7 and 1 is 0. It's 8, and 8 is a 0, and you carry 1. So here you could go to decimal, which is 7, 8, plus 5 is 13. And similarly, 13 minus 8, that will give me 5. So the answer is 5, but you carry 1. It's 1, 5. So this is how you add in base 8 or octal. And of course, you could try the calculator, programmer calculator, and check your answer. Let's see multiplication here. So multiplication here is the algorithm, similarly to the multiplication of polynomials, but let's see how it works. So first I multiply 1 with everything, and then we're gonna have to multiply. This is the 0. I put a dot just to differentiate between a 0 and the 0 in the multiplication. So to move to one side, because I'm gonna multiply by 0, I put a dot, and now I have, you could either move twice or just put so many zeros, because 0 times 1, 0 times 0, and so on. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Make sure you have everything lined up. Having a graph paper so you have every digit in a square helps a lot. So now I'm done with the multiplied by 1, multiplied by 0. Now I'm in 1. So again, instead of putting zeros, I'll put 2 dots, and then I'm gonna copy everything. So as you see, I multiply by 1 and multiply by 1 again twice, and now I'm gonna multiply by 0 twice. So I have 2 lines where I multiply by zeros. So as you see here, I multiply by this 0 and this 0. So I'm just crossing them because I already multiplied by 2 zeros. And then now the next thing is I'm going to multiply by 1, which is the last one here, last one. And the next thing I'm going to do is add all of this. So I have a 1. Remember, this dot means zeros, but it just helps me see what number I'm multiplying with. So we have a 1 and a 0. Again, 1 plus 1. Let me put here all the numbers. These are the number in decimals, and this is the binary. We may need them. So as you see, this is a 0. So 1 plus 1 is 2, which is 0. You carry 1. So 1 plus 1 again is a 0, and I carry 1. Now 1, 2, 3. I have 3. That means you put 1 and you carry 1. So 1, 2, 3 again. Put 1 and you carry 1. 1, 2, and 3. And 1, you carry 1. And now pay attention. 1, 2, 3, 4. So 4 ones. What is a 4? Is 0, 0, 1. And pay attention here carefully. I'm going to change my color so you understand this. So I have 1, 1, 1, 1. So it's 4. And 4 is 1, 0, 0. That means I put a 0, 0. And then 1 here. So my carry become in the third place here. So I moved twice because 4 is 0. You carry 0 and you carry 1. So I'll continue. So I have 1 and 1. So I'm in this. 1 and 1 is 0. I carry 1. So remember, I have 1, 2, 3. So 1 and you carry 1. 1, 2, 3. 1 and I carry 1. 1, 2. That means 0 and you carry 1. And then 1 and 1. So you could try this in your calculator and see if it gives you the same answer. So again, the most important thing is this. So for example, if I have 1, 1, 1 plus 1, 1, 1, just to make a point here, I'm adding all of them. So when I have 5 ones, and the 5 is 1, 0, 1. 1, let me change my color. So 5 here is 1, 0, 1. So 1, you carry 0 here and a 1 here. And then if I add all of them, it will be 5, which is 1, you carry 0 and a 1. So the next thing here, I have 1, the 1 in green and the 5 in red, so which is 6. And 6 is 1, 1, 0, 0, and I carry 1 here and 1 here. And then 1 and 1, it's 0, it's 2, which is 0, and you carry 1 here, and 1, 1 is 0 and carry 1. So I made this specifically just so you could see how we carry in binary. 1. So bulk multiplication in base 16, we'll do base 16 and then I'll do base 8. So base 16, if you look down here, I have a table, multiplication table. So you could look at it and see. So let's see this one here. So 2 times f is an e and I carry 1. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2 and a 0. 2 times a, if you look at the table, is 4, 1. So I'm done with the 2. You don't have to cross it, but just so you see what I'm doing. So the next thing we have here is I put a 0. So I multiply by zeros. That means 1, 2, 3, 4, 5 zeros, right? And the next thing I'm going to multiply by a c again. So 1 and 2. C times f. If you look here, here is c. And here is f. So c times f is 4 and you carry b. 4 and I carry b here. C times 1 is c plus b. So what is c plus b? You could go back to decimal and say c is 12, b is 11, and therefore is 23. And 23, if you minus 16, that will give you 7 and you carry 1. So that will be 7 and I carry 1. So c times 1 is c plus b, which is 12 plus 11. So c times 1 is c plus 1 is a d. C times 0 is 0. If you look at the table, you have c times a, which is 8, 7. You look at the table, you see that 8, 7. Now we go back to the b, and then b times f, 5, and you carry a. B times 1 is b plus a. So if you know, b is 11, a is 10. So that will give me 21. And 21 is what in base 16, if you minus 16, that will give you 5 and you carry 1. And I carry 1. I'm still in b now. So b times 1 is b plus 1 is c. And b times 0 is 0. B times a is e. You carry 6, but since the last one, I put 6. And now I'm multiplying 1 times everything. I'm just going to copy everything. 1, 1, 0, a. Now adding this. I have e, 3, 4, 5, 6. Now, where is 7 plus 5? That is c. because it's 12 and 12 is a C. And similarly, you could say that 4 and 5 is 9, so I have D plus F plus 9. D is 13, F is 15, and plus 9. Now if I add D plus F plus 9, 13, 15, and 9 is 37. So I'll put 5, and I carry 2. And now similarly, I have C plus 1, 2, 3, 4. So basically C plus 4. So C is 12, plus 4 is 16, and 16 basically is 0, and you carry 1. And then 8, 9, 10. We know 10 is A. And then E plus 7, that will give me 5, and I carry 1. And A, which is 10, plus 7, which is 17, that is 1, 1 in hex. And this is how we multiply in hexadecimal. For the next one, I have 6, 5, 2. This is base 8, multiply by 7, 5. So again, look at the table, or just do the multiplication in your head. 5 times 2 is 2. You carry 1. And 5 times 5. So again, here we go. 5 times 5 is 3, 1. 3, 1. Plus 2, 1 is 3, 2. So we put a 2 and you carry 3. And 5 times 6 plus 3, that will be 1, 4. Then I multiply by 7. Again, look at the table, multiply by 7. I'll get the following. And then remember, I'm in base 8. When I add, I cannot put 8 or 9 or 10. I need to go back to 1, 0, 1, 1, and so on. So here I have a 2. 6 plus 2 is 8, which is a 0, you carry 1. 4, 5, 6. This is 10. So where is 10 in base 8? So again, you could minus 8. You have 2 left, and where you carry is 1 because you subtracted 1, 8. So I put 2 and I carry 1. 5 and 1 is 6. And this is how you multiply in base 8. I hope this video is helpful.